The first question is, so they're asking the product for this question: chloroform, NaOH, H plus, and water. What is the product? So here we can expect the one product. Actually, there are two products for this. Let us see the product 1. So answer, product 1 is normal Raman reaction. So OH group is here, para position is completely occupied, so that normal Raman reaction CHCl3 NaOH H plus H2O. So CHO group will come to the ortho position, either to the position or towards this position. Both are ortho positions, but this ortho position is not preferable as it is a little bit crowded, so that the CHO group will land over this position. So we get the molecule. This is the product 1. And what must be the product 2? Product 2 is from the para position, and that para position is also not from the CHO group. So I'll take this OH. Initially this OH minus ion attacks over this H plus ion. Why? Because being a phenol, it is an acid, this is the base, so that there is a loss of water molecule. So we get the phenoxide ion. Actually this is not the phenol, it has some cyclohexyl group also side. So that to this, now you just add the dichlorocarbon CCl2. Imagine the delocalization is taking like this. We shall do like this, and this position will attack over here, means from this particular position. Now the double bond comes here. Here one double bond is there. Here double bond O. Here CCl2 minus comes. Okay. So now in this particular position, uh, carbon valency crossed almost reached 4. It is 4. So that there is no hydrogen to replace. So at this position, if H plus or protonation is done, then you don't get the aldehyde. You get another unexpected product. CHCl2. So this is the second product. Product 1 is the normal Raman reaction, and product 2 is not the normal Raman product. Actually, it is the para product of no aldehyde group. Now, let us see the second question. So, in this second question, this is the question: H2SO4, dilute H2SO4, and afterwards O2 H nu. Second one is again H2SO4. So we need to write down the two products over here. So directly I'll write the product after explaining the first step. Second step not necessary to explain. See here, this is the propene molecule. When H plus ion from the H2SO4 attacks over here, According to the Markovnikov's rule, we get the secondary carbocation. So this secondary carbocation will attack over the benzene and providing this, I am writing this product here. So we get the isopropyl benzene, CH, CH3, CH3. Just looking like Friedel-Crafts alkylation reaction. So here the product whatever is there, this is that product isopropyl benzene, and after isopropyl benzene, this is the O2H. Isopropyl benzene is also known as the cumene. So H2SO4, this is just oxidation. So we get the phenol, OH plus CH3CO, CH3 acetone molecule. Now let us see some other next question what I had given in the previous video. So the question is, phenol is subjected with the CH3COCl in the presence of the period. We got some product over here, maybe it is A. So A is on reaction with the AlCl3 is giving the product B. So this product B on reaction with NaOI is giving the product C. So let us see these three reactions here. First of all, phenol reacts with the acid chloride and gives, this is an OH group, this is an acid. So OH group, alcohol group, when react with the acid, esterification takes place so that we get the ester here. O, C double bond O, CH3. This is phenyl acetate. This phenyl acetate in the presence of AlCl3 undergo rearrangement. This rearrangement is known as the Friese rearrangement. So that you will get the two products over here. OH group that depends on the temperature. CH3 plus, one is ortho product, second one is the para product. Okay, and this particular molecule on reaction with NaOI, and this is the reaction of chloroform, the haloform reaction. I'll write iodoform, actually iodine is there, no? So it is the iodoform reaction. So in iodoform reaction, the molecules that are having the CH3CO group can react with the NaOI, or else you can write as I2 plus NaOH. So they convert the CO group into the CO minus group and the CH3 group into the CHI3. So the product here is salicylate, sodium salicylate, actually sodium salicylate plus CHI3 iodoform. So these are the reactions, and there is one more reaction what I had asked you to solve in the previous videos. That question was, let us consider as a fourth question. Okay, this is the question. So concentrated H2SO4 and heat it, and let us see the product. What must be the product over here? When concentrated H2SO4 is there, means automatically it is a dehydration reaction, means we need to remove the water molecule. So let us see the procedure of the reaction that is going to take place with this molecule. Here OH, here ethyl group. So H plus ion from the H2SO4 can be attacked by the OH group, so that here protonation of the OH group takes place, ethyl group and OH2 hydronium ion, so that it will be removed, or it will be eliminated as the water molecule, so that this particular cation will be formed. This cation's resonance. So we get the double bond here, double bond here, positive charge here, ethyl group here. This is the secondary carbocation. Secondary carbocation is bit unstable compared to the tertiary carbocation. So in this particular step, 1, 2 methyl shift takes place. So sorry, ethyl group. This is C2H5. Complete ethyl group will be shifted over to this particular secondary carbon position to generate the tertiary carbon. So ethyl group will come over here. Here double bond is there. Here double bond is there. Here positive charge. Now this is the tertiary carbocation. This tertiary carbocation, now hydrogen from in this position will be eliminated as H plus ion. Okay, to get the aromatic nature to this molecule. So this is the product for this particular reaction. So today we shall solve some other important theory questions which are very important, so that I'll write down those reactions here. You also note down and pause the video whenever you are watching and solve the question. I just put this one as a question. So the question is, prepare pentane 1-mole from pent 1-ene, 1-bromopentane, 1-bromobutane, 1-bromopropane. So let's try to solve the question one by one. First of all, option A. So in option A, we need to take the pent 1-ene as the reactant molecule. So pent 1-ene means CH3, CH2, CH2, CH double bond, CH2. This is pent 1-ene. So to this pent 1-ene, we need to prepare the pentane 1-mole. So 1-mole means OH group has to come over here. That is done only by using the hydroboration oxidation B2H6 in the presence of the THF. Step 1. Step 2 is H2O2 OH minus directly. So you shall get the CH3, CH2, 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 CH2OH. If you want to get the 1OH, 2OH, then you can use the mercuric acid and demercuration. Oxymercuration and demercuration also one of the step. So that can be used if you want to get the pent 2-ol. Next, B. From 1-bromopentane, it is easy. CH2, 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 Br. So this is 1-bromopentane. To this just need addition of the nucleophile. So you can take the aqueous KOH, or in examination they may mention like this also, OH minus in the presence of the H2O, both are same, no problem. So this nucleophile OH minus attacks over here and replaces this bromine, since it is a primary alkyl halide, so that CH2, 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 CH2OH. This is pent 1-ol. Let us see the question number of C, 1-bromobutane. Now the number of carbon atoms are less. In these two questions, number of carbon atoms of the reactant and product are same, but the number of carbon atoms in the question number C are less, that is 1-bromobutane. So CH3, CH2, CH2, CH2Br. This is 1-bromobutane. So we need to increase the number of carbon atoms. That can be done by cyanide process or creation of the Grignard reagent or Gilman's reagent or lithium. Many carbonance procedures are there. So let us take the well-known reaction, that is Grignard reagent. So alkali halide with magnesium in the presence of the dry ether, it forms Grignard reagent, CH2, 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 MgBr, and carbon gets the negative charge. Magnesium is always with the positive charge because magnesium is a metal and carbon is the non-metal. Now we have to put a primary alcohol. Primary alcohol, Grignard reagent gives the primary alcohol only with the formaldehyde. So attacks over here, shifts over there. So we get the, I'll write this one as a C4H9. Now COMgBr, here two hydrogen atoms already present. Okay, 1 minute, I did mistake here. Here, okay, MgBr. Okay, this is correct. This is fifth carbon. No, I thought it is a fourth carbon. So this carbon it is. So this is okay. Now subject with the H plus and H2. So hydrogen here and OH here, disconnect this bond. So we get the molecule of CH3, CH2, 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 CH2OH, pent 1 ol. Now they're asking about the from the 1 bromopropane. So still it is having the less number of carbon atoms. Now 2 carbon atoms are less. Okay. So when 2 carbon atoms are less, then how to do the molecule and how to create it? Let us take the CH3, CH2, CH2, Br. This bromopropane, 1 bromopropane. Subject with again magnesium in the presence of the dry ether, so that we shall get the CH3, CH2, CH2, MgBr, Grignard reagent again. Now the wonderful step here is just take the epoxide. So Grignard reagent attacks over here and opens this ring, so that here we get the CH3, CH2, CH2. Now this CH2 is connected to this CH2, CH2, and this CH2 lost the bond here, and so next bond is with another CH2, later O minus. So do the protonation in the presence of the water. So we get the CH3, CH2, 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 4. This is the fifth one. So totally 5 carbon atoms. This is pent 1 ol. So in this way you can solve the questions. So what I request is, every time you just for initially copy the question, try to solve yourself. If not possible, then you see the answers while seeing this video. Question number 2. Second question. So these are the 3 questions. How will you synthesize N-butyl alcohol from the acetylene, allyl alcohol from the propane, glycerol from acetylene? So first of all, let us solve the question number A. Sub question A. So in this sub question, we need to take the acetylene. CH triple bond CH. This is an acetylene. They are asking N-butyl alcohol. So our duty is to increase the number of carbon atoms initially. So what we do is subject this acetylene with 1 equivalent of sodium, not 2 equivalents. Okay, so 1 equivalent of the sodium, or you can take it as a 1 equivalent of the sodamide. Sodamide is a base, this is an acid, so that H plus will be replaced, so that we get the CH triple bond C minus Na plus monosodium acetylide is formed. This monosodium acetylide can easily attack over the alkyl halides, so that higher alkanes can be produced. So let us take the CH3. We need 4 carbon atom species butyl. Already 2 are there, so that you take the ethyl bromide CH2 Br attacks over here and replaces the bromine, and NaBr will be eliminated. So we get the CH triple bond C CH2 CH3. So this is the molecule. What we got is 1 butane. So this 1 butane you subject with the again sodium liquid ammonia, or else you can take the palladium carbon calcium carbonate or barium sulfate in the presence of the quinoline or sulfur, whatever it may be. The reason is we want to reduce it to the only 1 mole of H2 has to be added, because we want the alcohol no, so that we need again double bond, so that it becomes the CH2 double bond CH CH2, now CH3. We want N-butyl alcohol. N-butyl alcohol means one alcohol we want. So that if you directly with the HBr if you do, and later if you go for the aqueous KOH, you will get the 2-butyl alcohol, not the N-butyl alcohol. So whenever you want the antimarconic of alcohol from the alkenes, then your best method is to go with the B2H6 THF. Second one is H2O2 and OH minus. This reaction has been discussed in our previous videos. You can check for any explanation or for any clarification. So that you will get the CH2 OH here, CH2 CH2 and CH3. This is N-butyl alcohol, common name. So question number A is over. Let's go with the question number B. Allyl alcohol from the propane. So this is allyl alcohol from the propane. Let's take the propane molecule. CH3, CH2, CH3. So just do the chlorination in the presence of the sunlight. Take more amount of alcohol, less amount of the, so that here not only chlorination, you can take the bromination. Bromination is more preferable than the chlorination, as it compulsory gives the secondary product, secondary substituted product in the case of the bromination. So we get the 2-chloropropane. This 2-chloropropane, when you subject with the alcoholic KOH, so there is it's a dehydrohalogenating agent. There will be loss of HCl molecule, so that we get the CH3 CH double bond CH2. So propene molecule has been created. So to this propene molecule, they are asking of what? They're asking allyl alcohol. So we need to put the OH group at this allylic position. This is an allylic position. So you just do here two things. We can go in a two ways. I am giving almost all the possible reagents which can substitute at the allylic position. First reagent is chlorine at a high temperature, 500 degrees centigrade. You must remember the temperature. Otherwise, if you take the chlorine at the lower temperature, the addition reaction will take place at this double bond, not at the allylic position. Or else, you can go with the N-bromosuccinimide, NBS. Okay, so N-bromosuccinimide you need to take. So when you take the N-bromosuccinimide, the reagent means the solvent is important. That may be alcohol. It is soluble there only. Better you take the carbon tetrachloride, not the alcohol, as succinimide is floating over the CCl4, and I had given complete explanation about the NBS. We are using the CCl4. You can please check that video, and bromosuccinimide. Or else third one, SOCl2. So SOCl2 also do the halogenation at the allylic position. So basically these reagents will substitute one of the halogen at this allylic position. This is an allylic position. If you take the chlorine, here chlorine comes. If you take the NBS, here bromine comes. If you take the SOCl2, here again chlorine comes. So that since we are using different reagents here, chlorine and bromine, so that I'll put X here. CH2 X CH double bond CH2. Okay, and now to this you need to put the silver hydroxide Ag in the presence of the aqueous. So this OH minus ion can easily replace this chlorine or a halogen from the allylic position, so that we get the allylic alcohol. So question number 2 is over. Let us see the question number 3. So glycerol from the acetylene. So let us see the glycerol from the acetylene. So C. Again you take the acetylene. Glycerol means 3 carbon atom species and acetylene means only 2 carbon atoms. Then how to convert this acetylene into the glycerol? So you just take the, initially you subject with the HgSO4, H2SO4 and H2O. Means we are doing the hydration process. So acetylene on hydration gives acetaldehyde. Okay, this acetaldehyde when subjected with the H plus KMnO4, its main duty is to convert this one into the carboxylic acid. So this carboxylic acid is subjected to the calcium hydroxide, so that we get the calcium acetate CH3COO taken twice calcium. This calcium acetate just subject to the distillation, heating. So it gives acetone. 3 carbon molecule has been produced. So now an interesting reaction is chlorine and heat it. Interestingly, ketones and aldehyde they react with the chlorine and substitution takes place at the alpha carbon to the carbonyl carbon. So that one chlorine here and one chlorine here. So we'll get the CH2Cl, C double bond O, CH2Cl. So these reagents are very crucial because these reagents generally we don't use in much reactions. We are aware with these common reagents, but these reagents helps us in providing the key step products. So this type of reactions please do remember. And next you just subject with the aqueous KOH. So both of these chlorines shall be removed. CH2OH, C double bond O, CH2OH. So this keto group has to be converted into the alcohol group. Then our simple concept is lithium aluminum hydride. Okay, lithium aluminum hydride in the presence of water H plus. So we get the CH2OH, CHOH, CH2OH. This is the glycerol molecule. So in this way we can prepare the uh, glycerol from the acetylene. So these are all belong to the different lessons, but we are combining them in this question. So let's go for the another question, another important question. There are many important questions. So third question, question number 3. The question is, third question, give the mechanism of acid catalyzed dehydration of ethyl alcohol if the reaction is carried out at 170 degrees centigrade when ethene is formed. And second question is same the acid catalyzed dehydration of ethyl alcohol, but now they are asking at the 140 degrees centigrade. And third question is 3,3 dimethyl butane 2 loses a molecule of water in the presence of concentrated sulfuric acid to give tetramethylethylene as a major product. Suggest the suitable mechanism. Okay, let us see them. So first one is dehydration of ethyl alcohol C2H5OH, concentrated H2SO4 at 170 degrees centigrade, formation of ethene. So for this we need to provide the mechanism. CH3 CH2OH. So H plus from the H2SO4 alcohol is protonated CH2 hydrogen, so that here CH2 OH2 plus loss of water molecule, so that carbocation is the intermediate here, so hydrogen CH2 plus loss of H plus, ethene has been formed. Now this everything takes place at the 170 degrees centigrade. When you change the temperature, the dehydration process will be changed completely. Now C2H5OH, same ethyl alcohol, and catalyst, acid catalyst also same, concentrated H2SO4, but the temperature is 140 degrees centigrade. So the product is diethyl ether. So for this we need to provide the mechanism. So let us take the initially ethyl alcohol CH3, CH2, OH, H plus N, same step. Initial step is same, protonation of the alcohol. So it gives the CH3, CH2, OH2. So that this has been left H2O. So that CH3, CH2 plus cation has been created. So now this cation will be attacked by the another ethyl alcohol. Lone pair of electrons attacks over here. So we get the C2H5. Okay, I'll write like this. CH3, CH2, oxygen, hydrogen, CH2, CH3. Okay, now loss of the H plus. So you will get the C2H5O, C2H5. Diethyl ether is the product when you use the 140 degrees centigrade temperature. And the next C question is they are asking product reactant is 3,3 dimethyl butane 2-ol loses a water molecule in the presence of the concentrated H2SO4 to provide the tetramethyl ethylene. So first of all, let us write down the reaction, then go for the mechanism. Okay, so C. So the reactant molecule initially is CH3, CH, OH, C, CH3, CH3, and CH. Give the numbering 1, 2, 3, 4. 3, 3 dimethyl butane 2-ol. So subjected with the concentrated sulfuric acid, and the product is tetramethyl ethylene. So this is the product. So let us see the mechanism, how the product has come. So in the mechanism, initial step is the same, protonation of the alcohol, OH, C, CH3. These are the three methyl groups. H plus from the acid catalyst, protonation takes place. Okay, so that hydronium ion shall be created. Later C, CH3 taken thrice. I am writing all these at a time. So loss of water molecule. So we'll get the CH3, CH plus. Okay, carbocation. I'll write it properly. So now CH3, three methyl groups are there. Now it is secondary carbocation which is a bit unstable, so that one of this methyl group will be shifted over here. So it is called the 1,2 methyl shift. So we get the CH, CH3, CH3, C, CH3, CH3. Here positive charge will be created as it lost the methyl group. Now I'll write down this particular hydrogen C. We can write the hydrogen like this also separately. So for this step there is a loss of H plus M. So we get the double bond between these two carbon atoms, and each of these carbon will get the methyl group. This is the tetramethyl ethylene. Hope you understand. Let us see another question. Some other question. So question number 4. Now I'll read the question once again. An organic compound of formula C3H8O3 yields on acetylation with an acetic anhydride a derivative of the formula C9H14O6. How many hydroxyl groups are present in the compound? So they are saying indirectly that this molecule is an alcohol molecule, but it may have the 1, 2 or 3 OH groups. As I said, so it may be 3 OH groups are there, sorry, 3 oxygens are there. We may think they are the 3 OH groups, or it may be aldehyde or 2 OH groups, or it may be one ester group or 1 OH group, or it may be a carboxylic acid 1 OH group, keto group 1 OH group, like that. Any ether also possible. So that we cannot say that all the oxygens belongs to the OH groups. That we need to find it out. So first of all, acetylation they said, and acetic anhydride derivative of the formula this molecule has been formed. So basically, if you see alcohol when react with the acetic anhydride CH3 C double bond O C double bond O CH3 acetic anhydride, there is a loss of acetic acid like this, and this oxygen shall be, sorry, 1 minute. So it shall be removed like this, acetic acid, and the C double bond O group shall be connected to this oxygen. So we get the R oxygen C double bond O CH3. What is the difference between this basic alcohol and this ester? Here one alkyl group and OH group is there. Here alkyl group as it is, same alkyl group is present here, and here one oxygen is present, and extra the difference here is 2 carbon atoms, 3 hydrogens, 1 extra oxygen is there, and here this hydrogen is there, no? So this hydrogen, if you remove from this hydrogen, then the original difference will be, difference between these two is C2H2O. So in this particular reaction, for every one OH group, so when you remove one OH group, what extra group you are introducing here? C2H2O. So that I shall write first here. In this reaction, for every OH group, one C2H2O is increased on acetylation. Okay, so here final molecular formula of the compound is of what? C9H14O6. So total increase, let us see, for every one OH group this much increase means total how much is increased? Total increase is equals to, take this one, C9H14O6, this is the molecule, minus original what molecule is present? C3H8O6 O3. So we'll write here, that is C3H8O3. So if you subtract this C3H8O3 from the C9H14O6, what you will get? 3 carbons, 9 carbons and 3 carbons means you will get the 6 carbons. Okay, and 14 hydrogens and 8 hydrogens means you will get the 6 hydrogens, and 6 oxygens and 3 oxygens means you will get the 3 oxygens. Okay, So this you divide with C2H2O, C2H2O. So it goes almost 3 times here. It also goes 3 times. It also goes 3 times. Means C3H3O means actually, no, sorry, it's not C3H3O. 1 minute. 1 minute. Okay. So it goes almost 3 times here. So 3 times means total increase is this much. And if you divide this molecule, because for every OH group, here for every OH group, this much is increased. So the total increase this much. So and this value by, for every OH group increased value is this much. If you divide this value, it goes almost 3 times, means there are 3 OH groups. So 3 OH groups are present. So the given organic molecule is having the 3 OH groups. Let's write down the another question. Maybe question number 5. I think the question is, give the structure of W, X, Y and Z in the following reaction. Reaction is given. Allyl alcohol subject to the chromium oxide with dipyridine in the presence of this H2Cl2. So W is the molecule. That on reaction with the methyl alcohol in the presence of the H plus gives the X. X on cold dilute alkaline KMnO4 gives the Y. Y on acid hydrolysis gives the compound Z. So let us try to solve this question as it has been asked in the previous IIT examination. So this type of the questions also may come in the IIT examinations, Roorkee 2000 examination. So let's try to solve this. First of all, allyl alcohol, CH2 double bond, CH, CH2OH. So on CrO3, C5H5N, CH2Cl2. Chromium dipyridine. This is an oxidizing agent which oxidizes the primary alcohol to the aldehyde, so that it is a mild oxidizing agent. CH, CH double bond O, aldehyde. And this aldehyde, this is an W compound. And this one on reaction with the methyl alcohol. So here methyl alcohol means they did not mention the 1 mole or 2 mole, so that you take the 2 moles of methyl alcohol. So 1 oxygen CH3, this is hydrogen oxygen CH3. The whole reaction is taking place at the in the presence of H plus, so there is a loss of one water molecule like this. Okay, so we get the CH2 double bond, CH, CH, O, CH3, O, CH3. Okay, so one molecule has been created. This is the Y. Sorry, this is W, X. This is an X molecule. So X molecule has been created. So this X molecule on reaction with the of what, cold dilute alkaline KMnO4. What is the role of cold dilute alkaline KMnO4? Cold dilute alkaline KMnO4 is a Bayer's reagent. Dilute alkaline KMnO4, its role is hydroxylation at the double bond. It will not touch other part. So that you will get the CH2OH, CH, CH, OCH3 and OCH3. So this is a Y compound. Now this compound on reaction with the acid hydrolysis, so it is H plus and H2O. So acid hydrolysis, this will be broken. H this side and OH this side, H this side, OH this. So indirectly they used this reaction as the protecting group to the aldehyde. They want to protect the aldehyde because aldehyde will be oxidized if you use the cold dilute alkaline KMnO4. So directly if you put the cold dilute alkaline KMnO4 here, OH, OH, here COH will come. So that's why they want to protect this aldehyde by using the methyl alcohol or ethyl alcohol. Okay, so now the molecule will be CH2OH, CHOH and CHO. This is the Z compound. So I'll give one more problem to you. You solve this problem at home. This shall be discussed in the tomorrow's class. Question number 6. The question is, A gives B in the presence of Al2O3 to 50 degrees centigrade. B gives C with Hi and AgOH. C gives again B with Al2O3 150 degrees centigrade. B again gives the A with B2H6 followed by H2O2 OH minus. This has been asked in Root Key 2000 examination. So in this question, in the above reaction scheme, A and C are the isomers. So this A compound, C compound are the isomers. B has the formula of C5H10. So this formula is given. Means this formula means automatically this formula C5H10. And B molecule which can also be obtained from the product of the reactions of C3CH3CH2 MgBr means ethyl magnesium bromide and acetone. Remember that first of all you need to do ethyl magnesium bromide and acetone reaction and you will get one product, and from that product, see here they clearly said C5H10 which can also be obtained from the product of the reactions of these two. So from these two reactions you will get one product, from that product you will get the C5H10. Okay, so then you automatically will get the structure of the both of these compounds. So when these compounds are identified, you can easily identify A and A compounds and C compound also. So I request you solve this question and send it to me. Tomorrow we shall discuss the same question. Hope you understand my explanation, and if you find the products for this, please do comment in the comment box, and do not forget to subscribe the channel. Thank you.